Okay, right. So let's look at the next page. Consider the forces on the person when the bicycle is not in motion. All right, there you go. Right. So the center of gravity of this person is slightly outside, right? Acting around here. Next, we know that there must be normal reaction forces from the wheels upwards. So if you look at the distance here, this is about 1. This unit length of distance is about 1, and this is about twice that distance. Right, so there will be uh, normal reaction forces 1, N1, and normal reaction force N2. Notice how I have drawn the length of the arrows. Right, in fact, it's not perfectly right. Right, I should draw the weight slightly longer. Right, such that when I draw the vector diagram, if I may draw the vector diagram, the weight N1 and N2, and N2 should come back to the same point. But why did I draw N1 longer than N2? Well, consider taking moments about center of gravity, right? N1 times 1 must be equals to N2, which means that the value of N1 is twice the value of N2, which is why I draw N1 roughly twice as long as N2. Okay, so this is a simpler case. Let's now try and look at it when it is in motion at constant speed. Object that's at constant speed, it means that more or less, no, it means that it must be in equilibrium. Okay, so let's use the same estimation of length to do a simple estimation of the forces available. So first, we'll have weight roughly around here. And now let's give the guy a value. Let's say it's around 600 newtons, which is about 60 kg. Right, so this will be the weight here. The length here is about 1 units. The length here is about 2 units. Right? And here we have to apply a third length, right, which is the height of the CG above the wheel. This is roughly about 3 units. Right. So once we have these dimensions down, we can look at the forces acting on him. That's the weight. That's the normal reaction force N1 and N2. Right, let's just draw them in first. Let's not care about the length. N1 and N2. But because the bicycle is moving, there must be forces acting on the wheel. And when you pedal, right, there's a force acting through the back wheel, right? There's a force acting forward on the back wheel, which I will draw here and label as F in blue. But for him to travel at constant speed, it means that there must also be air resistance pushing him back. So if we look at the translational equilibrium here, we can say that F, the forward driving force, is equals to R, air resistance. The upward forces N1 plus N2 must be equals to the weight. Okay, so here we must make a certain assumption that the air resistance acts through the CG to make our lives a lot easier. How then do we find roughly or estimate the values of N1 and N2? We must now consider moments. If we take moments about the center of gravity, R and W, they will not produce a moment because they both act through the center of gravity. Right? Remember, we make the assumption that air resistance act through the center of gravity as a whole. So what can we say about N1 and N2 and F? Well, taking moments about the CG, what do we have? We have N1 times 1, giving you a clockwise moment, must be equals to N2 times 2, just like before. However, now we have one more force, which is the forward driving force times 3. With this system of equations, if we know the values of R, we can actually solve for each of these individual values. Okay, but here, what I want to let you know is the sensing here is that the value of N2 must decrease and the value of N1 must increase compared to before. Why? It's because F here has a certain value, which means that there is an additional clockwise moments, additional anti-clockwise moments compared to before. Right? Compared to before, over here, right? There isn't as much anti-clockwise moments. So here there's an additional anti-clockwise moments due to F. This means that the value of N2 must decrease compared to before, and value of N1 must increase because they still add up to the value of the weight of the person. And this actually explains why when you pedal very hard, the bicycle goes into a wheelie where you are only resting on the back wheel of the bicycle.